Hey guys, welcome to the Lux channel. So this is a follow-up video of my previous episode, which is episode number 226. In case if you haven't yet watched, I suggest you to watch the same so that you can understand what is the context I'm talking in this episode. So it's an research in terms of exploring the overheads of Linux socket subsystem versus something like message queues. But rather than discussing about message queues, I have done a demo code wherein which we can see the overhead of the overall socket communication, and in this case UDP based socket communication. So let's just ignore TCP aspect because it is not something we can directly compare with something like message queues, because there is something like a connection is involved. So what I have done is I have done a time-based network transfer output. I have modified the code slightly. So you can see here, this is the server code. Earlier I was doing some kind of a display of packets, reception of packets for every 1 million packets or so. So that I was doing, and apart from that I was displaying the received bytes in the form of 32-bit unsigned into 32-bit data type, since it is a fairly small value. So for every 1 million packets it is getting reset, and the counter is getting reset because it's just very small to hold such a large number. So what I did is I have refined the code, and this started giving an amazing analysis so that we can do almost a system level benchmarking with various systems. So what I have is I have this laptop which we can run the same code. I have this PC and I have another laptop, and we can see how the baseline performance changes with respect to each device type. In case if you guys do the same with Raspberry Pi, it may give a different output altogether. So you can see here I'm just recording the time, and then it is constantly getting the data from the UDP client, remote UDP client, the same localhost UDP client, and then it is just going to check if it has elapsed 1 second or so. It is going to display how many it has received those bytes. So you can change this resolution, and the way of changing the resolution also will change the output of total bytes received in that duration, because there is some amount of performance overhead involved by doing this for every second as well. So anyway, this is the sort of change I have done, and then it is going to display in that moment how many bytes it has received. And you can see here we are resetting the bytes count, and here it is just incrementing this bytes count, and before this while loop starts, here we are again resetting the bytes count or initializing the received bytes as 0. So this way it starts from 0, and each time it elapses a second it is going to dump the value, and then again it is going to restart, and then the cycle continues. So once it is done, again we are picking up we are registering the start time, and then it's going to do the same. So you can see here, and then once it comes here, if it has received anything, then it is going to save the length of received bytes, and then it is getting the time of the day, and then it is just checking, and it is just going to loop around. So this is the sort of modification and I have done, and I started to get something spectacular results out of the same. So we can go back here. You can see here I have done some test trial runs. So let me just show you guys. So I have kept 3 tabs open, and in this tab I can run the UDP server. So let us just run the UDP server. So it is registered, and then it is waiting for the remote packets from the UDP client. So we run this UDP client, and so with a single thread, with a single connection, as I described in the previous episode. So currently what we have is a scenario like this. You have the kernel space, and you have the user space, and here we have a client, and you have a UDP server, and it is just pumping the data. Here it is data, and inside the kernel it is packets in the local host or local loopback port. As I said in my earlier episode, we are not supposed to do in physical network ports. So it is just about testing the entire system's performance capabilities and stuff like this. So it is sending this packet, and then here it is receiving this data, and then it is counting the same. So in that case, in one single instance, it is getting on an average of around 4 GB or so. As such, you can see here it is it has received around 4000 MB bytes per second, which is actually 4 GB around, in and around actually. So let us run one more UDP client instance, socket client instance. So with this, you can see here it has almost jumped up and it has become almost double. So which means it is still not adding any overhead to the system. So it is able to cope up with this extra overhead. So it is now totally 2 instances are sending, and then we are getting around 9000 megabytes per second. It is not bits per second, it is byte per second. So if I run one more instance, so let us just run one more instance, as you can see here. So right after that, we don't have any extra change. In case if you notice, it has actually dropped down. It is showing around 9000 something as such. With just 2 UDP clients, it is around close to 9200, 9150 or so as such. So now there are totally 3 threads or 3 clients simultaneously pumping the packets or pumping the data, and its performance has dropped down. So this is the sort of tipping point for this system. So what we can do is we can cancel this, and then you can go back and analyze. You can see here it has come up once again, and it is showing around 9100 or so consistently, which means this is the sort of tipping point, and this is the max performance we can expect from this system. Although this is a very huge system and so features involved or processor cores involved, the point is the per core performance and everything matters end of the day. So what we can do is we can do similar experiment in a laptop so that we can see. Let me just cancel these threads before that. So we can just run the same experiment in this laptop so that we can analyze how far it differs. So I'm not sure it has a screen capture tool, and what I can do is I can do an offline print screen of the same so that you can have a look. So I'm inside, so let us just go in the folder UDP socket server, and let me open another tab, UDP socket client. So I'm going to do a static screenshot and going to embed in this video so that you can understand. So with one client, it is around 3.8 or 3800 Mbps, which is bytes per second, and with another client, UDP socket client, so with another instance, it has jumped up to 9800, which is impressive because it is almost at the same rate as this huge desktop. This is around 9150, whereas in this case it is around consistently showing around 9800 or 9500. But what happened is, since this laptop has bad internal thermals, the CPU throttling has came up, and then it has started throttling the CPU, so it is fluctuating between 9800 and suddenly its performance dropped down to 8200 or so. So once again you can hear. So let me get this laptop near the microphone so that you can hear the same. So you can get a picture. So you can see here the fan is revving up, and then it is coming down, and it is doing the same again and again. So while it is doing so, the performance is fluctuating. It is showing around 8200, and then slowly it is coming down to 6100, and then 5100. Let me just take a screenshot, and then slowly it is going down further down, 3100, and then 2100, and then now suddenly it started to climb up once again as such. So it is quite unique device. It is not having a sort of linear performance curve. So it has dropped down all the way to 1100, and then it has started climbing up once again as such. So let me just cancel the same so that it will stop this CPU frequency throttling, and then again it cools down the CPU as well. So this, you can see, it is a sort of unstable system. For this we can't say like it is able to tackle a fixed load, but every time it fully cools down and then you start the same, it starts with two UDP socket clients, it goes all the way up to 9200 or so. So there is another interesting laptop what I have here. This one is a 2-core 4-thread laptop. It's a Dell laptop. Yeah, this laptop doesn't do aggressive CPU throttling like that laptop, but of course this also does, but not so aggressive, and it doesn't get overheated like that laptop as such. So this laptop is again an interesting case where, let me just run this UDP socket server, and let me run UDP socket client. Yeah, so with one instance, this shows around 3500 megabytes per second, which is again quite impressive. And let me run one more instance, UDP socket client. So with this two instances, it shows around 5300 Mbps, and then so it has scaled up. So let me try one more instance, UDP socket client. So with 3 instances, it is around showing the same 5300 or so. So which means in fact it is little bit dropping down 5100 and so on. So which means that beyond this point it is not showing any improvement. In fact I think if I run one more instance, it is going to drop down the performance as well. So as far as I have done a couple of more experiments with a couple of my one of my students' laptop as well. So what I have seen is, as the way it has a baseline performance. So with one thread or one instance of UDP client, it gives so and so performance. With a couple of UDP clients, it climbs all the way up, and then with maybe 3 UDP clients, suddenly it may climb furthermore, and then slowly it will start dropping down. So which means it can't handle anymore. I mean, it doesn't go to zero, but it will start dropping down, and it will reach a sort of steady state. So only there is an exception with this device. It is a different case, because it is having this bad CPU thermal throttling. So due to that, its performance is going to be like this, somewhat like choppy. It goes up and down, and so on. So that's an exception with this laptop. But provided if you do this with any Xeon server, it is going to give a fairly bit a performance curve, somewhat like a bell shape overall like this as such. It is going to go up all the way up, and then after some time it is going to reach a saturation point, and then after that it is slowly going to degrade as such. So we should know that this is the sort of the point at the max it can handle this load. So hope you guys have enjoyed this episode. In case if you have done this research, of course, along with my previous sample code, you can download this as well, and then you can also run this in your systems, and then you can also analyze the same. And in case if you have find any interesting results, you can share with me. You can also discuss in email or discussion forum or YouTube comments. So hope you guys have loved watching this video, guys. Have a nice day. Bye bye.